Hi, Maciej here. Welcome on my channel. Do you want to understand performance tiers, access tiers, and blob lifecycle? So this episode is for you. Today I would like to deep dive into storage account service. Stay tuned. Hi, today we go deeper into storage account service and try to explain few concepts like performance tiers, access tier, and lifecycle. So let's start. But first of all, let's make some drawing. First of all, let's start about some concepts, cloud concepts, I would say, like region. So this is a region. And each region contains one or more availability zone, and each availability zone contains one or more data center. And what the availability zone is? Availability zone is a set of data centers separated between themselves about 100, for example, 100 kilometers. So they are proof for any disaster, for example. And each availability zone have own electricity, water, and networking, and so on. So they are high available and redundant. Okay, but let's go to the storage account and redundancy. The storage account have several redundancy options, which can be configured for storage account. First option is local redundant storage (LRS). And let's make some drawing to go deeper into this concept. LRS. So LRS is a single availability zone which contain few data centers and stored content, for example files, are replicated between each data center in this AZ. So there are at least 3 copies of our data. Okay, so this is the LRS. But we have also zone redundant storage, ZRS. They look almost the same, but there's 2 availability zones. There are 2 availability zones. And as previously, each AZ contains one or more DC data center. And our data is stored in each AZ, and they are replicated between each other. So we have at least 6 copies of our data. Okay, but there are more. We have also GRS, so geo-redundant storage. So as you already know, there is two regions. Whoa. There are two regions, region 1 and region 2. They are separated geographically, and each region have some AZ. Okay. And our data is stored in single AZ, but replicated between those regions. There is one disclaimer about regions. They should be paired regions, so we cannot choose, for example, West Europe and North Central. And in both regions, we could also write data into our storage account. And later, they're asynchronously replicated between of them. Okay, but there is not all. We could have also some other options, for example, GeoZone redundant storage. So as previously, okay, GZRS. So we also have two regions with AZ and with data center, and our data is replicated between regions and between availability zones as well. There are also another types of redundancy. Read access geo-redundant storage, as name suggests, is already known GRS mode, but data in paired region have only read access. There is also another option, read access zone redundant storage. This is also a variation of GeoZone redundancy, but in read-only mode. Okay, let's go to the performance tiers. So in storage account contains two performance tiers, standard and premium. Standard tier is optimized for high capacity and high throughput. Premium tier is optimized for high transaction rates and consistent storage latency. These are only quick summary of them. But what access tier, what performance tier choose when? Standard performance tier is great for general data storage, like media content, backups, large amount of data processing. On opposite side, there is a premium performance, which is great for small blocks of data, like from the IoT devices or machine learning, where software reads and writes quickly small chunks of data. Let's go into some demo. I show quickly how to create each of them. So let's begin. We start with the okay. With the standard performance tier, I choose the resource group. Let's some name. And we choose the standard. We can choose, for example, as you can see, when we choose the standard performance tier, we have all redundancy options. And we have also options like blob public access, storage account access keys, and so on. We have also table and queues. From the network perspective, we have the public endpoint and private endpoints as well. We can choose the Microsoft network routing or internet routing. From the data protection side, we could choose soft delete for blobs, soft delete for containers, soft delete for file shares, and so on. We could also select some tracking options. Okay, so let's create this storage account. Okay, in the meantime, I will create another storage account, which will be premium tier. Okay, let's choose the right resource group. What name I choose? Okay. Okay, let's choose the region and let's select the premium. And there is just one small change where we could choose the premium account type. We could choose the block blobs, page blobs, and so on. We have some descriptions as well, but from the redundancy perspective, we have only one option, local redundant storage. So when we have the requirement to have the data protected, we cannot choose this type of account, or we should design our application in another way. In the Advanced tab, we have almost the same functional options, but we cannot choose the data lake Gene2. From the networking, we have also the same, but on the data protection, we cannot choose the file shares and we cannot choose the tracking options. Okay, let's create. Okay, so this is the quick demo how to create each of type of storage account. Okay, but what about access tiers? There are three of them: hot, cool, and archive. The main differences are pricing, but also in time need to data access. Hot is optimized for storing data that is accessed frequently. So for example, our images from our web application. The cool is optimized for storing data that is infrequently accessed and stored for at least 13 days, so 1 month. And the archive tier is optimized for storing data that is rarely accessed and stored for at least 180 days with flexible latency requirements on order of hours. But we need to design our architecture carefully. Not because not all options of redundancy are available to all access tiers, as you already see on the previous demo. Okay, but when to choose what? There is a common question. There is a lot of stuff. In most common case scenario, the best choice will be standard performance tier with appropriate redundancy tier to our requirements with hot access. When we want to archive something or data is not accessed frequently, go direct to cool or archive tier. But remember the data should be stored at least one month or half of the year. Okay, so what about lifecycle management in blob storage? Lifecycle, in a few simple words, allow us to manage in automatic manner on which access tier our data is stored depends on the role defined by us. Let's go look how it works. So let's go into our resource group from the standard tier, where we can go into containers. We have only one. And under data management, we have the lifecycle management. We can define the rule. For example, let's give us some name. We can access this to all blobs. Okay, and as you can see, we can define some rules. For example, last modification date. Let's type 10 days. Then move to cool storage. Let's go next with the next. You can type 30 days. Move to archive. And when our document is stored half of the year, let's go delete this blob. So we can simply and quickly define the rules for our containers. We could also post option to filter, for example. Access to these blobs. So let's type 10 days, and we could type the filter set, for example, logs, because we have only one of them, and create this access rule. About storage account, we can discuss for a long time because it's one of the core services. But in my opinion, this is a key concept and most used by developers. Stay tuned for next episode where I explain another Azure service. Bye!